Good morning. John Gilkison, Aerostealth here. It is February 20th. It's 2026 and it's a Friday. And I've got a couple videos to shoot this morning, so I'm going to start with a solar system model for the Los Cruces bike trail. And this has been an idea that's been percolating in my head for a little while, and I had an opportunity to speak to the county commissioners on February 11th because I was a candidate for the bike trail committee. And I didn't get picked, but I got to stand up and speak on my behalf. And so I spoke about the bike trail and my experience with building a couple solar system models before this. One in North Texas State University at the Astronomical Observatory, and I also helped design a solar system model for the City of the Rock State Park in New Mexico, southern New Mexico. And this idea for a bike trail solar system model came up because I ran across a video of one of them in Brisbane, Australia, which is quite a tourist attraction, really. And the what I really liked about that particular model was the scale. And it seems like it's a magic scale of 1 meter equals 1 million kilometers. So basically the scale is 1 to 1 million. And it enlarges a solar system model, so it ends up being 5.9 kilometers long out to Pluto, but it's easily biked. That's only 3.6 miles, and it's still walkable, although it's the first part of it is probably the easier, the inner solar system. So to give you an idea, I'll just show you a quick map here of the bike trail. Now, the B section here up at the top, and then there's a C section over here. There's a section of the trail that runs from Valley Drive over to La Llorona Park, City Park, and you could use that for the model, and then also you could just use the park from one end to the other, and it might bleed over from one of these trails to the others. One of them is called the Outfall Channel Trail and the La Llorona Trail. So that was my proposal, to put the model there. And I included with my proposal just a solar system table, and in the yellow is the two parts of the table that were pertinent for figuring out the scales of the models on the trail and their distances apart. So anyway, I'm just going to go over these quickly. So wherever the beginning of the trail is, you have a model of the sun, and that could be a sign or a physical sphere. And it is 1.4 meters across. So that turns out to be 55 inches in diameter. And now, in the Brisbane model, you walk about 10 meters away, and then they have a model of Proxima Centauri. And what the signage says is that you would have to go circumnavigate the globe one time, go 40,000 kilometers, walk all the way around, or bike all the way around the globe and come back to where you were, and then go an extra 10 meters, and you end up with at Proxima Centauri. Now, bear in mind, the solar system itself is only 5.9 kilometers in extent. So 40,000 kilometers takes in the distance at a scale of 1 to 1 million to the nearest star. So, and later I want to talk about an addition to that, which I didn't fit in the proposal, but it turns out that the Voyager spacecraft, Voyager 1, recently reached a milestone of being 1 light day from Earth. And you could scale that into this model too, and that's quite interesting. However, so you start at the sun, you go out to Mercury, and Mercury's 58 meters away. And it has a diameter of 1/5 of an inch, you know, about like that, compared to your 55-inch wide sun. Now, the thing about this scaling is that all these scales would result in, let's say you had brought a telescope to the model, you could go where the Earth is and set up your telescope and look at the different models of the planets, Mercury, Venus, Mars, whatever, and they would appear the same size in the telescope as they appear in a real telescope looking at the real sky, is what I'm trying to say. So in other words, if you looked at Mars or Saturn or Jupiter in the real sky, or you just set your telescope up at the Earth model and looked at these other balls, if they were visible, which they should be if the model's laid out correctly, you could they would appear the same size in the telescope. And that's a nice feature. So anyway, you go on to Venus, it's 121 meters away, and it's a 1/2 inch in diameter. And the same is true of the Earth, it's a 1/2 inch in diameter, but it's 149 meters away. So as you can see right away, the inner solar system in our model over at City of Rock State Park is very compact. It's all within several meters. But in this model, you literally have to walk some little distance between the inner planets in the solar system. So, for example, Mars is 228 meters away. That's a couple football fields in length, and it's a 1/4 inch in diameter. Now, I threw in Ceres just for grins. And the reason I did that, I didn't say so, but Pluto has been defined as a dwarf planet now, and it's technically not a planet. So, but that won't fly in southern New Mexico because Clyde Tombaugh lived in Las Cruces, and so it's a planet. And so I threw in Ceres because it's also technically a dwarf planet. And we visited Ceres recently, so about 10 years ago, and it's an astonishing asteroid. It's very large, 480 miles across, and it's completely circular. Gravity at that scale just circularizes things. And so Ceres is 413 meters away. That's good 4 football fields. And it's only 1/32 of an inch. It's just a little tiny grain of sand. It's just a speck, but there it is. And now we get to the planets that are really visible, even in the model, and that is the planet Jupiter. It is 778 meters away, and it's over 5.5 inches in diameter. So you could have a real physical model of it easily. And that's 142 millimeters. You go on to Saturn, it's 1.43 kilometers away. It's 1,433 and 30, meters. And it's 4.7 inches. Now that's without the rings. The rings would definitely give it more of a presence than even Jupiter. up close. Uranus is 2.87 kilometers away, and it's just 2 inches in diameter, about like yay. But still, it's a physical model, you can see it. And Neptune is 4.49, might as well say 4.5 kilometers away, and it's 1.9 inches, slightly smaller than Uranus. And Pluto is 5.9 kilometers away, which is 3.6 miles, and that's the end of your model. Now, I've already included Proxima Centauri, but in the model I did in North Texas State University Observatory, I had a sign just beyond Pluto which said how far the nearest star was, and in the scale of that model it was in Santa Fe from North Texas. However, in this one, of course, you have to circumnavigate the globe one time and come back to it. Now, there's one addition which I don't have in this proposal, and that again is Voyager 1, which is 1 light day away. And I've worked it out. It turns out to be 16 miles, and whatever 16 miles is converted to kilometers. Let's see here. It's about 25.5 kilometers away. So, at any rate, it wouldn't fit in the model. You could, I think the whole bike trail is about 25 miles and all around the Los Cruces circuit. So you could do that. That's an interesting idea, but again, you end up right back to where you are, and that would get confusing with the Proxima Centauri thing of circumnavigating the Earth. But the interesting thing is you can just take 1 light day, and Proxima Centauri is 4.2 light years away. So 4.2 times 365. And that's how much further it would have to, Voyager would have to go to reach Proxima Centauri if it was going there, which it's not. And so it turns out that it's taken Voyager 1 48 years to get 1 light day from Earth. And it would take it 74,000 years to reach Proxima Centauri. So it's a bit of a scaling issue there. So I'll let you go. We got 13.5 minutes into this video. I just wrote up a 2-page proposal and sent it in to the city council, or excuse me, the county commissioners. And I have this planetary data sheet enclosed with it, and a map, of course. And I've already spoken to them about it, so it should be in their memory. And I sent 8 copies, one to Andrew Ray, who apparently organizes for the county commissioners and speaks to them about what's on the agenda and everything. And hopefully he should remember me too. I asked him to distribute these copies to the county commissioners. So we'll see if it goes anywhere. But at least I had a shot at it. I did get to speak to him. And now I've sent him in a written proposal just the other day. And I'll get back to you if there's any developments on this. But anyway, I'm going to close the video here for now. And I'm going to move on to my next video, which is going to be about how I've driven 120,000 electric-only miles. And I've done videos on this before, but not just an overview of how driving electrically has changed me. And it's based on experience. It's not based on conjecture on how I think. I love electric cars, and I've never driven one, but I think they're great, and so forth. It's based on real life experience. So we'll see if I can I'm just shooting these videos off the cuff. Maybe I can come up with something new that way. So I'll see you in the next video. Take care, everybody. Bye-bye.